Hey flight simmers, welcome to the channel. I'm the Cockpit printer and today I will show you how to design the Korry switch. The Korry switch is named after the manufacturer of the real switches and it's definitely one of the most iconic parts of a cockpit, especially the Airbus cockpit. First, I wanted to cover this topic a little bit later in the series, but there are many requests about it, so I made the decision to cover it right now. And by the way, it's a great opportunity to cover some more topics in 3D design and especially the approach to some more complex parts and assemblies. What I will show you today is just the result of a long journey I have with the Korry switch right now. I had the opportunity to fly in a real simulator in the past, and if you press one of the real Korry switches, it's such a nice feeling, and I wanted to replicate that feeling and I wanted to come as close to the real Korry switch as possible. I will divide this topic into 2 episodes. Today we are just focusing about the 3D design, and in the next episode we will cover the 3D printing and the assembly of the switch. If you are new to the channel, please make sure that you subscribe and hit the bell. But for now, just grab a cup of coffee and let's get to work. Let's have a look on the design of the Korry switch first before we start with the actual design. And the Korry switch contains mainly of 5 parts. We have the button in the middle with a little compartment in the middle where we place the circuit board with the LEDs. In there are 2 slots to feed the wires through, and in the middle there's just a pocket, and in there will the switch just plugged into, and it will hold in place just by friction. It's very nice. You don't need any screws or glue for this Korry switch. We will not design this switch. You will find the 3D design of it, the step file, in the link in the description. On top of the button there is the cover with the label, and as we did with the panels, we have a clear layer on top, and underneath there's a black layer with the pockets of the text. The button is placed in a housing, and inside the housing the switch is just slided into, and you don't need any glue or screws to fix it in place. All the way down here is a little strain relief. You can just feed a cable tie through it and hold the wires in place. On the side there are some reinforcements, because in the past I had some issues where the housing snaps into 2 individual parts. In this section over here it's a little bit weak, so I added these reinforcements on the side. And on top there's a little ring that holds the halo ring in place. And this lower ring, this is where the Korry switch is placed into the lower side of the panel. Okay, this is the overall design of the Korry switch. And before we start with the actual design, it's always a good idea to have some initial thoughts before we start with the design, because you can save a lot of work with some initial thoughts, especially if you have a part like this. If you have a look on it, it has a square shape, and that's always a good indicator that we can work with mirroring the part that we just design one half or 1/4 of the part and just mirror it to the other sides. We can save a lot of work by that. And in addition to that, it's always a good approach to start from the inside to the outside. We have a limiting the limiting factor of this Korry switch is the circuit board on the inside. We have a minimal dimension of the circuit board. It's 14 by 14 millimeters, and just by that it's a really good reason to start with the button, and from there we can work outwards to the housing and so on. All right, let's start with the design. Create a new design file and create a new component. Name it button. Create a sketch just on the top view. And when we have a closer look to the button, here you can see it's symmetric in both directions, the X direction and the Y direction. And with this, I can save a lot of work by just design 1/4 of the button and then just mirror it to the other sides. Let's create a 2-point rectangle over here. Give it a dimension of 7 by 7 millimeters. It's the inner dimension where we place the circuit board. Create an offset line. Make sure that the chain selection is deactivated, and just these two lines, -1 millimeter to the outer side. Close the gap over here, just with a line. And now I will add these little circles over here. With these circles, I will reduce the surface where I generate friction between the button and the housing. And if you have a large surface, and especially with 3D printed surfaces, when these surfaces are grinding at each other, it's a very bad feeling and it feels really cheap. And with these little cylinders, I'm able to reduce the surface. Later on, when the button is printed, I will just smooth this cylinder by grinding it off to size and remove all the grooves of the 3D printing. For this, I will create an arc, center point arc. From here, that's the center point. First point over here, second over there. And let's do this again over here. Give it a radius of 1.5 millimeter. And from the center line to the center of the circle, 5 millimeters. The wrong direction. And here is the profile of the button. Let's do an extrusion with all the profiles. And for the starting height, I will add an offset of -2 millimeters, because later there's the cover on top, and extruded a distance of -23 millimeters. Do another extrusion. From this object -20 millimeters. And this is a quarter of our button. And before I mirror this body, I will add a slot, the slots where we feed the wires through. For this, I'm creating a slot and a center point slot. First, select the center. It's on this center line. Then a second point over here, and then we can drag the slot. Give it a coincident constraint between this left line and this edge. Add a dimension, 10 millimeters, and a radius of 1.25 millimeters. Create another extrusion with this profile all the way down to this surface. Hit OK. And now we are ready for mirroring this body. Go to Create, Mirror, select the body, select the mirror plane, and Operation is Join. Hit OK. And now we have the half of the body. Create another mirror. This body, the mirror plane is this one. And now we have created the button. No, not yet. There's this little pocket missing in the middle for the switch. For this, create a sketch on the lower surface of the button, create a 2-point rectangle, and set the rectangle to center rectangle. Select the center point, and add some dimensions, 3.1 millimeters. And create an extrusion with this profile. Now the button is finished. And as you have seen, it's really simple and easy to do the mirror. And otherwise I had to create all these cylinders manually. And with just mirroring the part, we have saved a lot of work. All right, let's go on with the cover on top. For this, create a new component. Make sure that the parent is our global component. Let's start with a sketch on the top plane. And I will just project this geometry. Create, project, include, and project this face. Hit OK. And create a 2-point rectangle to close all the gaps over here. I will just drag a rectangle from side to side, and now I've closed all the gaps over here. Add some lines. First of all, a construction line in the middle. And then 2 more lines over here. Add a symmetric constraint between these 2 lines and the center line. Give it a dimension of 2 millimeters. And create an offset of these 4 lines. 1 millimeter. Hit OK. I will create the clear layer first, extrusion. Select all the profiles. And 0.2 millimeters. This is our clear layer. And create another extrusion with all the profiles again. Starting point is my object, the clear layer, the lower face of the clear layer. And I will extend it to an object as well, to the button. And that's important. The operation type has to be changed to new body. I don't want to add it to our clear layer. Set it to new body. Okay. And here are our two bodies. Just rename them. I just name it by color, clear and black. And if you want, just add an appearance. For the clear, I will use this glass. And for the black, plastic matte, like this. Okay, next I will add some walls on the inside of the switch, of the cover, I'm sorry. Let's select this profile. Starting height is this lower surface over here, -2 millimeters. And this is where we plug the cover into the button. It's held in place just by friction. And now I will add the little wall in the middle. Create another extrusion with these profiles. The start again is on this lower side and -10 millimeters. And operation, of course, is join. I'm creating a new sketch on the top plane again. And now I will add the label. For this, I will start with some construction lines. Add a coincident constraint to this construction line and the center point. And the same with this line. Now I create a projected geometry from this button surface, but not as a construction line. Hit OK. And this will be the frame of my on label. Create an offset of this line. Enable the chain selection. And 0.5 millimeters to the inner side. And drag this construction line on the center point of this rectangle. Create a text. Select this rectangle. Set the text to on, Arial narrow, typeface bold, the height 3 millimeters, and the alignment center and middle. This is the first label. Select it. Control C, Control V, just make a copy. And drag the center point on the intersection between these two construction lines. Add a dimension 4 millimeters and change the text to a veil. I will increase the height a little bit for this one to 3.5. Okay. Finish the sketch. Switch off the black layer and create an extrusion with all the profiles. -2 millimeters. Operation is join. Disable the clear layer. Enable the black. Create another extrusion. -2 millimeters, and operation is cut. Inside here I will create a new group for the black bodies. And now the button is complete. Let's go on with the switch in the middle. I will use a step file. You will find this step file in the link in the description. Just go to file, just download it, then go to file and open this step file. And then just save it. I have my YouTube project, and in there I have the parts folder, and in there I will just save the switch. Just save it. And now we are able to select this switch. Go to the parts folder, and here is the switch we just created. Drag it into the design screen. Now we have to place it in our assembly. For this I'm using a joint. And I will use the center of this face. If you are not able to select this center point, just hover over this face, press the Control key, and now this face is selected and I'm able to move this point just in the middle over there. And now we need the second component. The same again, I want to have this middle point, hover over the surface, press the Control key and select this point. And I want to have the pins on top. Just turn it by 180 degrees. Hit OK. And the switch is in place. Next, I will create the housing. Create new component. And here I will start again with a sketch on the top. And here I will just create the half of the housing and mirror the body later. Just create a 2-point rectangle. Add a coincident constraint to the center point. Then we need some construction lines. Create a projected geometry as a construction line. this line, and this arc. Hit OK. And with this, I'm able to add a tangent constraint between this line and this arc. Like this. Add an offset geometry of these three lines, but not as a construction line. Change the line type and 1 millimeter to the outer side. Hit OK and close the gap over here, just with a line. Finish the sketch. Create an extrusion with both of the profiles and the extend type to object, the lower surface of the switch in the middle, and to this with an offset of 2.5 millimeters. Hit OK. Create another extrusion for the pocket, this inner profile, and the extend type to object again, the upper surface of the switch with an offset of 0.75 millimeters. Add some fillets on the inner side of 0.5 millimeters and on the outside of 1.5 millimeters. Let's do the cutout for the switch. And for this, I will just use this surface of the switch, create an extrusion, select the surface, and drag it all the way to the right. And here is a cutout for the switch. Really easy. Let's go on and add another cutout to this wall over here that we are able to slide in the switch from the upper side. Create a sketch on this face. Create a projected geometry of the circle. Go back to the top view. And add some lines. Just a vertical line over here. And add a tangent constraint from this line to this circle. Cut the extension if you want. Just give it a dimension over here. And create an extrusion. There's one line missing. Okay. Add another sketch on this face. And we will add a little window here. Create a projected geometry. Of the bottom surface of the button. And from this side to this line, just 1 millimeter. Create an extrusion with this profile. Add a fillet in the corners, 2 millimeters. Next, I want to create a little bit of extra space over here, that we have a little bit more access with our soldering iron. Create a new sketch. Create a projected geometry. This line and this line. Finish the sketch. Add a chamfer. Modify chamfer on this corner of 4 millimeters. Then we need the slots for the wires. Create a sketch. Now the other half of the button is missing. Finish the sketch, go back to the button. Let's have a look why the half of the button is missing. And I already know, because we have this extrusion in the housing, the second extrusion, where we created the pocket for the button. And inside there, there's the objects to cut. And here are all the other bodies, the button and the cover. I don't want to cut these bodies, just the housing. Hit OK. And now the button is complete again. Let's go back to the last sketch. Create a projected geometry of this surface. Create an extrusion with this profile. Now I'm adding the strain relief. For this, just create a sketch. Create a 2-point rectangle and change it to center rectangle. Add 2 lines, one over here and one over here. Add a dimension of 4 millimeters in height. The width is about 3 millimeters. And 2 millimeters in the middle. Create an extrusion, 3 millimeter upwards. Hit OK. The second extrusion with this inner profile. If necessary, deselect the bodies, then you have access to this profile. Switch on the bodies again and 1.5 millimeters upwards. Now we have the slot for the cable tie. Add a chamfer, 1.5 millimeters. And now we are about to finish this housing. Now we are able to mirror the body. Go create and mirror this body. Mirror plane is this one. And now we have created the whole body of the housing. Let's create the two rings. For this, create a sketch. One of the side planes. Create projected geometries of this line. Create a line from there to the side with this profile. Like this. Add some dimensions from the top to this. It's 3.2 millimeters. The height over here is 1 millimeter. The width is 2 millimeters and the angle is 45 degrees. Over here, let's add a coincident constraint from the top to this line. It's 10 millimeters. The height of this line is 1 millimeter and the angle 45 degrees again. Finish the sketch. And now I will use these two profiles to create a sweep. These two profiles, and my path is this upper chain. And here are the two rings. Really easy. And the last thing I will do is to add the little reinforcements. Create a sketch on the bottom. Create a projected geometry. Either go to create and project, as we did several times, or just simply press P. Create a construction line with this line over here. Create a 2-point rectangle. From here to the other side. Add some dimensions. The height is 2 millimeters. And from the center to the lower line, it's 4 millimeters. And I'll simply add some construction lines for mirroring these geometries. Create mirror, window select these profiles, mirror line, the center line, and one more mirror, mirror line, this line. Create an extrusion with all of the 4 profiles, all the way upwards to this face, and set the operation to join. Hit OK. And now I've added the reinforcements. Now the housing is complete. Just change the name of the body to housing. Let's do this as well with the cover. Now we have already cover. We have already the button, bodies, and button. Create a new component. Name it Halo. Create a sketch. Create some projected geometries. Simply press P and we are in the project functionality. Geometry is this one and this one. Add a line. something like this. We have to add another constraint for this line, horizontal for this line, add some dimensions. Upper width is 1 millimeter. This height is 2.2 millimeters. And from here to the corner, set it to 1 millimeter. Now there's a dimension missing. Now I picked the wrong edge. From here to there, it's 1 millimeter. Now the line is black, it's fully defined. Finish the sketch and create a sweep again with this profile, and the path is the upper chain of my housing. Create a new body. Rename it into Halo and change the appearance to glass. And here is the halo. And like we did with the other templates, I want to create a cut body. I will use in the panels to do the cutouts in the panels. For this, create a new component, name it cut, hit OK. Create a sketch on one of the side planes. Create a projected geometry, press P, change to bodies, select the halo ring and the housing. Now we have created this profile. Create a center line, but very important, not as a construction line. One here, and close the gap over here. Add a horizontally constraint. Finish the sketch. Let's create another sweep. All these profiles, don't forget about the halo. Switch on the visibility of the housing and use the outer chain as the path. And here we have created the cut body. We need the reinforcements. And for this, I will just use the combine feature. Combine, the target body is my cut body and the tool body is the housing. Operation is join. Keep the tools. I don't want the housing to be deleted. And if you want, you can just extend these 4 faces all the way down, but you don't have to. And I want to give it a little bit of extra space in the panel, and I will simply pull these faces outwards, just 0.25 millimeters. And now this is a point, it's a little bit easier to pull these faces before we do the sweep, before we do this combine, because right here these faces are not splitted, and I don't have to select all the faces between the reinforcements. Select these faces, not 25.25 millimeters. Move the timeline backwards and it's easier to select all the faces before we have the combined feature. Do another press pull with the reinforcements. I want to have a little bit more extra space, 0.5 millimeters. And add a chamfer. One millimeter, like this. Okay, when I'm toggling the housing, you can see that the housing is just highlighted on these faces and on the upper face and nowhere else. That's fine, but I want to have a little bit more space between the panel and the housing, and for this I will create another press pull to these surfaces. Now I selected the right faces. Okay, and 0.25 millimeters outwards. And now when I'm switching on the housing, you just see the housing over here, but that's just fine on the chamfers. But on these faces, you don't see the housing. So we have enough space between the housing and the panels later. All right. Let's clean it up a little bit. Make sure that all the components we have created are ground to the parent. Now we don't have to ground the switch because it's already connected to the button. And because it's still unsaved, save the whole document. Select the path. Give it a name, Korry. Save it. And for the panels, I have to create a label. For this, I will create a sketch. No, I will create a new component. That's important. And name it label. Create a sketch on top. Create a vertical construction line and 2 horizontal construction lines. Create a text. Title 2, area narrow, height is 3 millimeters, alignment center and middle. Drag it onto the intersection. Now you can see the title is tilting. Add a horizontal constraint to one of these lines. Create a copy. Control C, Control V. Hit OK. Drag it on the intersection. Change the title to title 1. The height is 3.5 millimeters. and some dimensions. $50 millimeters, and let's give it 5.4 millimeters in between. Finish the sketch. And I want to have these labels in a separate document. And for this, I will select the label, right click, and save copy as. And in here, copy label. I will name it label Korry. Save it. And you can either delete this component or just make it invisible. All right, just on top, make the Korry active and add one more sketch on the top plane. And in here, I will just add a circle. Circle of 25 millimeters. And I will use this circle to place the Korry switch in my panels. Let's give it a try. Create a new design file. Go to the templates folder. Drag in a panel template. Create a sketch on top. Place one circle in the middle. Go to the Korry folder and drag in a Korry switch. I have to save the Korry switch that the sketch is visible with the circle. And here is the circle. Create a joint. This circle to this circle. Hit OK. All right. All the components are moving into place. If that's not the case and there are still some components over here, that's because not all of the components are grounded to the parent. If that's the case, simply go right click and ground to parent. As you can see right now, the label is not in place, but now we have grounded it to parent. When we update the Korry switch, the title is in place as well, but I will not use this title or this label. I want to use this individual design file because I don't want to break the link to this Korry switch. Hit OK. Add a joint from here to there. I actually don't like to select this point over here. Let's open up the label Korry. Edit the sketch and add a construction circle in the middle like we did. And the Korry switch itself. Save it. Go back and update. And now we have this circle, and I like to select these circles for referencing the parts. Like this. And now we are able to select the Korry. Make the cut body visible. create a combine. I'll first break the link to the panel. Make the panel, or the top component of the panel, active. Create a combine, the clear layer, and cut the cut body of the Korry switch into the clear layer. Let's do this again with the panel. Switch to the bottom component, make it active, combine these two. And when we are switching off the Korry switch, we have the hole and the panel. That's working really, really nice. And now we have a new template. We're at the end of part number 1 of the Korry switch. Today we did the 3D design in Fusion, and in the next episode we will cover the 3D printing and the assembly of the Korry switch. If you haven't done it yet, please subscribe to the channel. If you find this video useful, please give it a like, and see you in the next episode.